10 real exam-style questions for the 2026 Databricks Data Engineer Associate certification. Pause after each one, lock in your answer, and count your score. Question 1. For 2 years, your team has run a nightly optimize with Z order by device ID and event type on a billion-row IoT table. New dashboards filter only on region and get zero benefit. So you switch to liquid clustering on all 4 columns. What fundamentally changes? A. Nothing about ordering. It's still a static lexicographic sort, so filters only benefit left to right through the declared columns, like a composite index. B. The delta transaction log is replaced by a clustering metadata index. Enabling it breaks all existing time travel snapshots. C. It's only cost-effective under 500 gigabytes because clustering stats must fit in the driver's memory. D. Data is co-located across all clustering keys at once. Any subset of keys gets data skipping, and clustering is maintained incrementally on new writes, without full table optimized rewrites. The answer is D. Liquid clustering co-locates data across every clustering key at the same time, so those new region-only dashboards get data skipping too, with no fixed left-to-right column order. And here's the part people miss. It's incremental. Newly written files get clustered as they land, instead of waiting for a full table optimized rewrite like Z order. That composite index behavior in option A, that's exactly what liquid clustering removes. The transaction log stays, time travel keeps working, and no, there's no 500 gigabyte ceiling. It's built for huge tables. Question 2. You support 3 workloads. 1. A data scientist exploring a raw dataset interactively in notebooks for hours. 2. A nightly automated 5 terabyte ETL job that must be cheap and fully isolated. 3. 30 analysts running concurrent SQL from a BI tool over JDBC all day. Which compute mapping is right? A. 1. All-purpose cluster. 2. Job cluster or serverless job compute. 3. SQL warehouse. B. 1. Serverless SQL warehouse. 2. All-purpose cluster with 30-minute auto-termination. 3. Job cluster exposing SQL endpoints. C. 1. Declarative pipeline cluster. 2. SQL warehouse running the PySpark through the API. 3. All-purpose cluster in high concurrency mode. D. 1. Job cluster flagged as dual purpose. 2. All-purpose cluster with a 240-minute timeout. 3. Job cluster with Photon for the JDBC queries. The answer is A. Interactive session-based notebook work belongs on an all-purpose cluster. The automated nightly batch belongs on a job cluster, or serverless job compute, because it provisions fresh, runs isolated, and dies the moment the job completes. That's the cheapest correct answer. And 30 concurrent BI analysts over JDBC? That's exactly what SQL warehouses are built for. Queuing, auto-scaling, query isolation. Remember the traps. SQL warehouses don't host notebooks and can't run PySpark. And keeping an all-purpose cluster alive for a nightly job is just burning money. Question 3. Autoloader trivia the exam loves. Which source storage systems can Autoloader read from, and which file formats does it support? A. Cloud Object Stores only. S3, ADLS Gen 2, and Google Cloud Storage. DBFS is excluded because it can't emit file events. And the formats are JSON, CSV, Parquet, and Avro only. B. Only S3 and ADLS Gen 2. 7 formats, but XML requires a separately licensed connector library. C. S3, ADLS Gen 2, Google Cloud Storage, Azure Blob, that's the deprecated WASBS scheme, and DBFS paths. With all 8 formats, JSON, CSV, XML, Parquet, Avro, ORC text, and binary file. D. It's a metadata-only controller. Actual reads are delegated to Spark batch readers, and every path must be a registered Unity catalog external location. The answer is C. Autoloader reads from 5 source systems: S3, ADLS Gen 2, Google Cloud Storage, Azure Blob with the deprecated WASB scheme, and yes, DBFS paths too. And it supports all 8 file formats: JSON, CSV, XML, Parquet, Avro, ORC, text, and binary file. Most people undercount both lists. DBFS is a supported source. XML needs no special license. And autoloader talks to storage directly. There's no external location registration requirement, just to read. Question 4. Your autoloader stream was started with an explicit schema, and cloudfiles.schema evolution mode was never set. 2 weeks in, the provider's JSON files start including 2 brand new fields. What happens by default? A. The default is fail on new columns. The stream stops immediately, so nothing is silently lost. B. The default is none. The new columns are dropped silently, and the stream keeps running. And add new columns isn't even allowed with an explicit schema. C. The default is add new columns. The schema evolves automatically, without interrupting the stream. D. Evolution modes only apply to inferred schemas. With a user-provided schema, the stream always stops and waits for manual intervention. The answer is B, and this is the trap. With an explicit schema, the default mode is none. Those 2 new fields are silently ignored. No failure, no rescue, just missing data, unless you set the rescue data column option. Add new columns is the default only when the schema is inferred, and it's not even allowed with an explicit schema. Schema hints aside. If you want unmatched data captured, that's rescue mode. It lands in the rescue data column. And if you want the stream to stop and tell you, that's fail on new columns. Know all 4 modes. The exam will mix them up on purpose. Question 5. A nightly customer CSV. You must update email, phone, and updated on existing customers matched by customer ID. Insert new customers, and never delete customers missing from today's file. Which merge is correct? And where does describe history report the updated versus inserted row counts? A. Update set star, insert star, plus when not matched by source then delete, required to avoid duplicate inserts, counts live in operation parameters. B. Use upsert into, Delta's recommended single-pass alternative to merge for large CSV loads. C. Matched update plus not matched insert, plus when not matched by source then delete. Safe as long as the CSV always contains every live customer. D. Matched update plus not matched insert, with no delete clause. Counts in operation metrics, num updated rows, and num inserted rows. The answer is D. Requirement 3 says absent customers must survive. So the merge has exactly 2 clauses. When matched, then update, and when not matched, then insert. That's it. The moment you add when not matched by source, then delete, every customer missing from today's CSV gets deleted. Exactly what was forbidden. And merge doesn't insert duplicates on matched keys, so that justification in option A was a lie. Upsert into doesn't exist in Delta SQL. The row counts land in describe history, in the operation metrics map, num updated rows and num inserted rows. Question 6. PySpark window functions, per store ID ordered by sale date. You need a running total of revenue, plus a previous day revenue column, the previous row's value. Which window setup is exactly right? A. One shared window, partitioned by store ID, order by sale date, and call both sum over and lag over on it. B. Sum over a window with an explicit rows between unbounded preceding and current row frame, and lag revenue, 1 over the ordered window. C. Sum over rows between current row and unbounded following, and lag revenue, -1 for the previous day. D. Use the built-in functions running total and previous row over the ordered window. The answer is B. A true running total needs the explicit frame, rows between unbounded preceding and current row. Here's why option A is the sneaky one. Without an explicit frame, an ordered window defaults to a range frame, which lumps together every row that ties on sale date. 2 sales on the same date, your cumulative sum silently goes wrong. Option C sums forward instead of backward, and lag with -1 peaks at the next row, not the previous one. And option D, running total and previous row sound lovely, but those functions simply don't exist in PySpark. Question 7. A workflow chain, task A, then B, then C, then D. Task C failed on a transient network timeout. A and B succeeded. D never ran. The root cause is fixed. What's the correct, efficient way to resume without rerunning A and B? A. Delete the failed run. Trigger a fresh manual run from task A and watch C closely this time. B. Temporarily remove tasks A and B from the workflow definition. Run C and D alone. Then restore the original definition. C. Databricks jobs run now with a start task flag pointing at task C, passing B's outputs to downstream tasks as environment variables. D. Use clone run to duplicate the run. Manually skip A and B in the clone settings, then trigger it. E. Open the failed run in the workflow's UI. Choose repair run and rerun only the failed and skipped tasks, C and D. The answer is E. Repair run exists for exactly this scenario. From the failed runs page, you re-execute only the failed task and the downstream tasks it caused to be skipped, C and D here. While A and B's successful results stand untouched, everything else on that list has a problem. Starting over from task A wastes compute. Editing the production workflow definition to skip tasks is risky surgery you never needed. There is no start task flag on the CLI. And clone run creates a brand new run configuration. It doesn't repair the failed one. Question 8. A 4-task asset bundle workflow ends with task 4 sending the success or failure notification, so it must run even if tasks 2 or 3 fail. In the job resource YAML, what's the correct configuration? A. Depends on all 3 upstream tasks with outcome success on each, the only supported outcome type. B. Plain depends on in the YAML. Then manually add an on-failure path in the UI after deploying. The bundle YAML can't express this. C. Give task 4 no dependencies and its own schedule firing 10 minutes after the workflow usually finishes. D. Outcome success or failed on the dependencies for tasks 2 and 3, and outcome success for task 1. E. Depends on tasks 1 through 3 and set run if all done on task 4. It runs once all upstreams reach a terminal state, success or not. The answer is E, again. The task level run if condition controls when a task fires relative to its dependencies. All done means run after every upstream reaches a terminal state, success, failure, or skipped. Exactly what a notification task needs. The other run if values are worth memorizing too. All success is the default, then at least one success, none failed, and all failed. And that default is the trap in option A. With outcome success, your notification silently never fires the day something breaks, which is precisely the day you needed it. The YAML fully supports this. No UI surgery required. And success or failed isn't a valid outcome value at all. Question 9. You must share sales data with 3 recipients. 1. An internal team on Databricks in a different cloud region. 2. A partner running open source Spark. 3. A subsidiary on its own Databricks SQL warehouse. Which statement about delta sharing is accurate? A. Databricks to Databricks sharing works cross-region, but Unity catalog lineage stops at the metastore boundary. Open sharing lets plain Spark read without any Databricks account, and all delta sharing access is read-only. B. Recipients get read-write. The internal team can write model outputs back into the shared tables. That's the advantage of Databricks to Databricks over open sharing. C. Recipients must be on Databricks. The protocol depends on Unity catalog credential vending, so open source Spark needs a Databricks personal access token. D. Delta sharing is only for external organizations. Internal cross-region access should use a shared external location instead. The answer is A. All 3 clauses hold. Databricks to Databricks sharing happily spans regions, but Unity catalog lineage graphs stop at the metastore boundary. You won't see cross-region data flow in lineage. Open delta sharing is exactly that, an open protocol. Any Spark client can consume the share with no Databricks account at all. And delta sharing is strictly read-only, for everyone. There is no write-back path, not for internal teams, not for anyone. If a recipient needs to send results back, that's a separate pipeline, not delta sharing. Question 10, last one. 4 scenarios. A. Ad hoc SQL exploration of a production PostgreSQL before designing an ETL pipeline. B. A 500 million by 200 million row nightly join against Snowflake, feeding a dashboard that needs sub 3-second queries. C. Querying a legacy MySQL audit database under Unity Catalog governance without moving the data. D. 100,000 events per second of Kafka ingest into Delta. Where is Lakehouse Federation the right call? A. Scenarios A and B. Federation pushes the giant join down into Snowflake's engine, delivering sub 3-second dashboards at zero Databricks compute cost. B. Scenarios B and D. Federation's caching layer materializes warehouse joins and foreign catalogs support Kafka streaming sources. C. Scenarios A and C. Fast no-migration exploration, plus Unity Catalog governance extended over external data in place. D. Scenarios C and D. Foreign catalogs govern the MySQL data and handle Kafka streaming natively with ACID guarantees. The answer is C. Lakehouse Federation has two headline use cases, and this question hands you both. Exploration without ingestion. Query that PostgreSQL in place while you're still designing the pipeline. And governance in place, Unity Catalog lineage and fine-grained access control over the MySQL audit database with zero data movement. What Federation is not? A performance engine. A 500 million row join feeding a sub 3-second dashboard belongs on ingested Delta data. And Kafka streaming ingest is autoloader and structured streaming territory. Foreign catalogs don't do streams. And that's all 10. Count your score. 8 or more, you're ready for the real thing. Tell me your score in the comments. And when you want full-length practice exams for this certification, they're waiting for you at testlogichub.com.